Good day, everyone. At this moment, we will be talking about the number of elements in a group and a subgroup. This is G and Valerie B. Montecalvo, your presenter. A group G is a collection of elements together with a binary operation which satisfy the following properties: closure, associativity, identity, inverses. A binary operation is a function in G which assigns the element of G to each ordered pair of elements in G. For example, multiplication and addition are binary operations. Classification of groups. Groups may be finite or infinite. That is, they may contain a finite number of elements or an infinite number of elements. Also, groups may be commutative or non-commutative. That is, the commutative property may or may not apply to all the elements of the group. Commutative groups are also called abelian groups. Finite groups and subgroups terminologies. The order of a group G is the number of elements in the group. The order of a group may be finite or infinite. The order of an element A is the smallest positive integer n such that A raised to n is equal to E. The order of an element may likewise be a finite or infinite. Note that if the order of an element A is equal to 2, then A is equal to its inverse. And if the order of an element A is equal to 1, then A is equal to E. A subgroup H of a group G is a subset of G together with the group operation, such that H is also a group. That is, H is closed under the operation and includes inverses and identity. Note that H must use the same group operations as G, so the integers mod n is not a subgroup of the integers, because the group operation is different. Definition: the order of a finite group G is the number of elements in the group and is denoted by the symbol given. Proposition: if H is a subgroup of a finite group G, then the order of H divides the order of G. For example, if the order of group G is equal to 14, considering the proposition, the possible orders for the subgroup are 1, 2, 7, and 14. Next. Definition: the order of an element G in a group G is the smallest positive integer n, such that G raised to n is equal to E, or n times G is 0 in additive notation. If no such integer exists, we say G has infinite order. The order of G is denoted by the symbol given. For example, U of 18 is equal to 1, 5, 7, 11, 13, and 17. So, the order of the group U of 18 is equal to 6. Also, we can write it by using 5 and finding the modulo 18, which we can have 5 raised to 1 is 5, 5 raised to 2 is congruent to 7 mod 18, 5 cubed is congruent to 17 mod 18, 5 raised to 4 is congruent to 13 mod 18, 5 raised to 5 is congruent to 11 mod 18, and 5 raised to 6 is congruent to 1 mod 18. Therefore, the order of the group of 5 is equal to 6. Additional example. Let G be a group where X is an element of G. If X squared is not equal to E and X raised to 6 is equal to E, prove that X raised to 4 is not equal to E and X raised to 5 is not equal to E. Proof. Suppose X raised to 4 is not equal to E, then X raised to 8 is equal to E. That implies X squared times X raised to 6 is equal to E, and implies X squared times E is E, and implies X squared is equal to E. It is a contradiction, so X raised to 4 is not equal to E. Then number 2. Suppose X raised to 5 is not equal to E, then X raised to 10 is equal to E and implies X raised to 4 times X raised to 6 is equal to 6 and implies X raised to 4 times E is E and implies X squared is equal to E. So another contradiction. So X raised to 5 is not equal to E. Therefore, the order of the group X is 3 and the order of the group X is 6. So that ends my presentation. For more clarifications, just leave a comment and I will answer it. Thank you and God bless.